Good morning, everyone. First of all, thank you for resisting the urge to get lunch and staying here instead. I know it's been a long day and yesterday as well, so thank you for being here. I hope you'll find it worth your while. So this talk is actually a little bit of a departure for me. I largely do defense and automation-oriented talks, but this one I thought was a message that needed to get out anyway, so I thought let's try it out this way in a different way. So this is a little bit more attack-focused, red team style focused. It's not, I will talk a little bit about defenses, but it's going to be largely attack-focused, especially given the time we have. So this is called an attacker's view of serverless and GraphQL. Now, serverless by itself, GraphQL by itself are obviously, there's a lot of content in there. You have a lot of different ways in which they can get compromised and have a lot of different ways in which you can secure them. However, I thought it is important to cover both these things in conjunction simply because you're going to see a lot of these type of stacks being deployed moving forward, is what I feel. I'm not in the prediction business, but I feel that this is what is going to happen moving forward. This is me. My name is Abhay. I run V45. We're an application security company. We do a lot of training, pen testing, architecture reviews, threat modeling, and so on. In fact, we have also a lot of cool open source projects. One is our correlation tool, which is Orchestron, which is the community version is on GitHub. We have, in fact, a lot of this conference is about threat modeling, and we have a threat modeling as code framework where you can use threat models and build them into your CI/CD pipelines. That's called Threat Playbook. You want to look at it, you can. We're building in a lot of new features on that as well. 2 weeks before coming into this conference, we released a new open source tool called DVFAS, or Damn Vulnerable Functions as a Service. These are intentionally vulnerable serverless functions that you can use, deploy on your own Amazon Lambda stack and run it and test it out and see how attacks on serverless functions work. Again, don't run this on production. Don't run this on your AWS account on your workplace. That's not obviously going to be a good thing. But to learn how things go, you can probably try out DVFAS. We have a bunch of DVFAS stickers, so after the talk you can come and see me and I can give you guys some stickers for DVFAS. So this is not the first time I've spoken about serverless at this event. We just finished a training. We just came off a training on serverless on 22nd and 23rd, serverless containers and Kubernetes. So this is kind of an extension of what we were talking about there. I do see some familiar faces in the room, so thank you for coming out. So first of all, I want to say this. I'm not some kind of an expert of any sort, so please don't expect that I'm going to give you a lot of nuggets of wisdom. It's not going to happen. It's probably just going to be a lot of attack-focused stuff. Again, I learn from the community as much as I try and give back, so obviously, please keep that in mind. So let's get started. So today's session, I'm going to quickly cover this because I do have some demos, so I would like to keep some time for question and answers. So I'm going to start off with a gentle introduction to serverless and GraphQL. Now this, I'm sure a lot of folks in the room probably are not quite familiar, especially security folks may not be 100% familiar with what serverless is, what GraphQL is. So I'm going to do a quick recap of this. Again, it's not going to be a very large recap. I'm just going to try and stick to the essentials. Then I'm going to look at an attacker's view of serverless itself. So we look at attacker's view of FAS. FAS is functions as a service, and it's not the only type of serverless thing around, right? You do have backend as a service, you have functions as a service. I'm going to focus on functions as a service for this talk. Again, the reference point is largely going to be with AWS Lambda and not, of course, you do have Google Cloud Functions, you have Azure Functions, you have all of these different FAS implementations or FAS frameworks. I'm going to focus on Lambda because it's probably the most used. Again, the concepts in here probably apply elsewhere as well, so you can use the same concepts. GraphQL, of course, is a standard technology. You can use, GraphQL is pretty widely used. In fact, it's getting heavily used in a lot of stacks. In a lot of modern stacks, you would see that GraphQL is becoming extensively used, especially where there is a lot of mobile footprint, right? When there is a lot of mobile footprint, you see GraphQL being extensively used because you want to have multiple clients working with the same application API style environment. So you see a lot of GraphQL. Of course, I have demos, and we will conclude with some understanding of what is an attacker's perspective of these two types of technologies and the the conglomeration of these two technologies, essentially. That's what I'm going to be talking about today. Of course, I do have a lot of demos, and as always, whenever demos are involved, I have to say a silent prayer to the demo gods. I'd really like you all to say the same prayer for me. There are some live demos. I do have some videos, but largely live demos, so I'm going to try and see if I don't mess it up entirely. Right? So let's get started with serverless. Right? So serverless, or what we call functions as a service, is something that has a lot of different meanings, especially serverless, because you have things that you run back-end authentication systems which you don't need to maintain infrastructure for, like Okta, whatever it is. That's serverless. DynamoDB, where you run databases that are completely managed for you, is serverless. All of these things are serverless as well. However, what we're going to be talking about is functions as a service, where you can deploy single-purpose functions onto a cloud environment, or you can run them, of course, even on containerized environments or even virtual machine environments, but typically you see them running on your cloud service providers like AWS, Google Cloud, and so on and so forth. You do have some open source variants like OpenFaaS and I think FN, and of course IBM has their own OpenWhisk and so on and so forth. So functions as a service essentially is us trying to move faster, right? So we had monoliths where you had this massive application with a ton of features, and then we realized that, oh my God, it's a hellish thing to maintain this. It's going to take years and years. By the time we make a feature or we try and release a new feature, we break 300 other features and a lot of problems happen, so you can't do your DevOps and all of that stuff with monoliths, right? It's not that you can't do it, it's that much more difficult. So all of us started espousing, hey, let's go to microservices. Right, let's start building smaller services, smaller, more independent, discrete services that you can use. So let us say you have user management as one service, billing as one service, payment as one service, purchases as one service. You might have a bunch of services, and you obviously have different stacks. You probably deploy them differently. However, they're all talking to each other through some kind of a message queue or some kind of a glue that you have in form of a message queue, and so on and so forth. So you typically had monoliths which became microservices. And then we realized, why not make this a smaller unit of compute? We realized, okay, during sign up, there's only our create user function that's being invoked a lot, right? During a sign up process, let's say we are a hot new startup and we want people to sign up for our service, like invite only thing before we actually issue invites, then you obviously see that the create only function is being used a lot more in our microservice. Then we realized that if we want to scale this particular function independently, we probably need for it to have its own compute environment. It should probably scale on its own, have its own setup, have its own set of dependencies, and run with it, right? So that's why you would probably have a scenario where you have create user, which is a single function deployed as a function on Lambda or Google Cloud or whatever it is, and that's being called millions and millions of times, and obviously you have to whatever extent you want, and that's the only function getting used. So you have a bunch of different functions that you're using, and these functions in totality make up your application, or what used to be your microservice, or hopefully a monolith. But again, a lot of people just try and push these two into this and say that, oh, we are using functions as a service, but that's also some of the issues that they face. But anyway, this is ideally what we're going for. We're going for the smallest unit of compute. We realized that we wanted just this individual function to run, and that function obviously has its arguments and it produces some output, and that's typically what your function is, right? So functions are triggered via events. Now, any function can be triggered via events. Now, when a user sends an HTTP GET or a POST or a PUT call, that is an event. Functions can also be triggered via third-party events. Now, let us say you upload a file onto S3, and a function is triggered as soon as the upload happens, or an object is created in S3. That is an event, right? User sends a text message to your messaging gateway. A function is triggered based on that text message, and some action takes place. That is an event. Or you get a message queue, your message queue on SQS gets a notification or a message coming in, and you trigger a function based off of that. That is a third party. That is also a function getting triggered via third party events. So you have various sources of events that are triggering functions, not just your typical API or web services style functions that you used to know. So functions are not only used for web services or to create API, you can also use them for reacting to different events across your cloud environment or across your deployment, so to speak. So now what typically happens when an event is triggered is that they would trigger either a container or a micro VM. In Amazon's case, we've learned that it's micro VMs. They use their own micro VM framework. This micro VM comes up, runs the function, and immediately goes into a frozen state. Right? Now the frozen state is to make sure that you don't really run any background processes after that. So the ideal thing is you run the function and that's it. It's a one and done kind of a thing. So it's like your CGI, right? If you think about it, it's very similar to how CGIs used to execute, where you had individual processes getting spawned every single time a request used to come in. In this case, of course, there is a huge amount of difference because you have your cloud scalability, you have scalability built in by default. Again, you don't have any, they don't have any ports. Functions don't really have any ports. You are accessing them through the API gateway, but the API gateway is the one that's actually handling the communication, but the function by itself is not handling any network communication itself, right? So there's no real network attack model, so to speak. However, there are different things that can go wrong. So that is typically, it triggers a container or a VM, and of course it executes something, whatever the function you want it to execute, and then it freezes post-execution. And of course, there are different states. I'm not going to get into the states. They're warm and cold and so on and so forth, but there are different ways of tracking all of that stuff, but I'm not going to get into that. The idea is a container spawns or a VM spawns, runs the function, brings it down. That's typically what happens in a functions as a service scenario. Right? So functions are usually single purpose. You can't do too many things within a function. You can't do, hey, do this, run a user, or create a user, then validate something else with the user, or do something else. Or you can't run too many dependent activities on a single function. You probably need to call other functions when you want to do that, but ideally speaking, you have single purpose when a function is in play. Right? Again, no ports. So if the function by itself does not have any ports, it's not exposed on port 80 or port 443 or whatever it is. It is called by different events. Of course, those events or those event sources might have their own service ports and so on, but typically functions by themselves don't have ports, right? They don't really have the network attack layer included. So that is one thing. They don't really have state. So one of the things that you would find really hard to do with a function is do state management with the function, because the function kills itself as soon as the function is executed. So that's something that you have to keep in mind, right? And they're short-lived. One of the things you should keep in mind is that you can't run let us say, one of the things that I would love to do is run a zap scan on a function, at least a 1 hour zap scan. That's not going to happen, simply because functions probably time out at, I think there's a maximum of 5 minutes. I'm not sure. 15 minutes? Okay. There's a maximum time limit that you can give a function. There's a maximum memory that you can allocate for a particular function. So you have these constraints, but if you have architected your application to work with those constraints, obviously your application would work with those constraints given whatever you have configured the functions for. Like I mentioned before, your events could come from multiple sources. So very commonly things like S3, whenever an object is created on S3, you trigger a function. Whenever an object is coming through a message queue, you trigger a function. Of course, when a user sends an API request to your function, which is behaving like an API, it would come through the API gateway, or it could come through your IoT scenario where you would have a network of sensors that are essentially sending or publishing events to a pub-sub interface, and that is triggering a function in the backend. So you have a lot of these different use cases that functions can be used for. You can also use functions for scheduled events, right? So let us say you want something to run every 5 minutes or every day or every year. So a lot of common use cases in an Amazon scenario is running a function every year to rotate your KMS keys. So that's a very common use case to use functions for. So a lot of times you would run scheduled events as part of functions, so you can do that quite easily with functions. A lot of the function as a service tooling like Chalice or Arc.codes or Claudia.js and all of that stuff allows you to configure these events or react to these events. So you have these events that you can work with. As I mentioned before, you deploy your function as a zip file with all the dependencies that you need, And in the Amazon's case, of course, you have a CloudFormation template that requires you to create the function, create the log groups that it has, all of the necessary privileges for that to run. The function is invoked whenever the user calls. Of course, it invokes either a container or in Amazon's case, a micro VM. And then, of course, they are frozen once the function is executed. So let me just quickly run a function deployment for you right now. This is a function that just gets in, you're allowed to, so it uploads a YAML file and stores it in the database somewhere. That's really what this function is doing. So it's getting a YAML file as input, as an upload, and it's storing the YAML file in the database. I'm just going to look at, I'm going to show you how you can deploy this. I'm going to be using Chalice for deployment, so I'm just going to, so this is my function. So you can see this. This is all it is. It has a single route. I think it has two routes. It has a test route and it has a YAML upload route, and that's all it's doing. So when you test it, of course, it sends back a success test. And when you upload a YAML, what it does is that it stores the YAML. I'm not written the storage code, but ideally it should write it in the contents of the YAML into a DynamoDB table. That's all it's doing, right? So you can upload a YAML, and that's what it really does. So you can look at, you can see that this behaves very typically like an API, right? So you can see that it's very similar to Flask or any other web service framework that you would have seen, where you can write something like this and get it running, up and running. So deployment is pretty easy as well. Most of the times you have tools that will do the deployments for you. So you have tools like Chalice, you have tools like Claudia.js, you have tools like arc.codes. All you have to do is there is a particular config file or some kind of a dot directory that you have to include as part of the function. What these deployment tools would do is, first of all, identify the app that is running your function, load that as a handler, and essentially package all the dependencies, store that in a zip file, and then send it over to AWS, upload it to S3, and then, of course, from there, the function becomes operational. Many of them also do IAM privilege management for you, as in they create your roles that is required for the function to run. They might allow you to allow the function to write log events to CloudWatch, all of that stuff, right? So you typically have a lot of IAM privilege that is assigned by the deployment managers. That's also another security gotcha, simply because if the deployment manager gives you more permissions or privileges than necessary, there's a good chance that you could get hosed because of that. So the deployment managers kind of take over the process from now on. So you have different deployment managers like Zappa, Claudia.js, Chalice. I'm using one from AWS called Chalice. So I'm just going to deploy this function. So it's a very simple thing. So you can see in my directory, I have the app.py, which is the actual code. The payload.yaml is not important. Requirements.txt is my Python requirements file, which is going to pull from PyPy when a function is loaded in. I also have my custom Python libraries or dependencies in my vendor directory. That's essentially what this is. So let's say I have a bunch of custom Python code I want to introduce or want to import into this function. I'm going to put that in my vendor directory. That's what's really happening here. It's reasonably simple. I'm just going to run a command, which is chalice deploy. And what this does, it creates a zip file, as I mentioned before. It creates a zip file, and then of course it also creates it updates the policy. So let us say I made a change in the IAM role or policy that I need. It updates the policy, updates the function. I've already deployed this function a bunch of times, so it just runs a update of that existing deployment. You can bring it down equally simply with a chalice delete or a chalice destroy. I'm not sure which command, but one of those two commands, chalice delete. I think it's chalice destroy that allows you to do that. There are a lot of deployment managers that also allow you to convert otherwise traditionally monolithic or microservices style apps to functions as a service. So there's one called tryserverless.org. I don't know how many of you, it's called SLS in short. So what that does is that you can write out a YAML spec, like very much like you can write a Kubernetes spec or so on. You can write out and say that this is my application, my function is in this particular app.py. I need Python 3.6 or Node 8.1 or whatever it is. You can mention the runtime environment that it needs to work, the deployment file that it needs to write, and it generates the file and deploys it for you and does whatever you need it to do. So you can see that the function has now been deployed on AWS. There is a ARN, and the ARN, it's a particular ARN, and there's a REST API, because since this is accessed through the API gateway, it also gives you a REST API that you can use to access the function. In the event that your function does not have any REST API like functionalities, it would just deploy the function and not give you any REST API URL. It would just tell you that the function is deployed. And of course, you can call it via those third-party triggers, right? So that's what your, so just a quick demo of the deployment of a function as a service. Now I'm going to quickly get into a little bit of background on GraphQL, and then we'll look at the attack, of course. So GraphQL is essentially an API query language, right? So what it does is that instead of you writing hundreds or thousands of API routes, what GraphQL allows you to do is query your final database, or query your API through a layer which it provides. And this layer essentially allows you to query specific information. You don't have to essentially query the whole thing. A lot of times, for instance, if you look at the GitHub API, you will see that if you do that in typical REST API, you would see that a ton of information comes back to you, right? You would see a ton of massive JSON coming back. Every time you query, say, fetch all my repositories, and I have a bunch of repositories, it would give me a massive JSON object that has all my repository names, it has all the necessary fields allocated with that, all the necessary attributes associated with that, all that comes back. That's a pretty huge data set. Now, what GraphQL allows you to do is, through a specific query language, specify saying, look, I want my repositories, I just want the URL of my repositories. I don't want anything else. So just give me my repositories and the URL of those repositories. And what it does is that it comes back as JSON, except that in this case, it's optimized and it only gives you, or it returns your repositories with the URLs of those repositories and nothing else. You can use GraphQL to insert data, which is called a mutation. You can use it to query data, which is, of course, a query. You can also use GraphQL to do subscriptions. So let us say you want to publish real-time information somewhere. Whenever data gets added to your API, what GraphQL does is, through a subscription, would trigger a notification to some webhook or whatever it is that you want to do, right? So GraphQL has a bunch of functionality. It's from Facebook, by the way. So I think it's now an independent foundation, but it started off as a Facebook project, but now it's kind of become a little bigger than that. So they've broken it up into a separate entity, is what I've heard. I'm not 100% sure on that. So REST versus GraphQL. So this is typically what you would do with REST API, right? So you would probably be familiar with something like this, where you have API, organizations, list, etc., etc. You have a ton of URLs, you have a ton of routes, and each of these routes need to be configured. You need to write the business logic for each of these routes. Now with GraphQL, all of this goes away and just becomes this, right? So you essentially say, use this /GraphQL, and all of the queries that you do are handled by that GraphQL resolver or that GraphQL layer that allows you to query stuff, mutate stuff, and so on and so forth. So so you typically have GraphQL types, which you could query, or you could insert, or you could subscribe to. These go into resolvers. This is where your business logic or your function actually plays in, where you would write something saying, okay, mutate. So let us say I want to add a user. I would create a mutation, and this user would be added to my database through the code that I write in the resolver. So the resolver essentially takes care of managing the actual business logic of what's happening within my GraphQL app, right? So there's a database. Of course, it can talk to multiple databases at a time. You can hook it up to not just a database, you can also hook it up to another API. So let us say you want to hook it up to MySQL, you want to hook it up to Mongo, you want to hook it up to Elasticsearch, you want to hook it up to another API, you can do that, and it would give you a very similar representation. So again, with GraphQL, you have different types of servers, you have different types of products that have become pretty popular. One is the Apollo product, which has become quite a dominant standard when it comes to GraphQL, especially on JavaScript. Python is something called Graphene, which I use quite a bit. Again, you have different, I don't know about the other languages, but you typically see Apollo, Graphene. I think Graphene has language bindings for multiple languages apart from just Python and JavaScript. So simple terms, again, you can define object types and fields, so which means you can say, hey, this is a user has name, age, email, password, whatever, right? You can define those as types and fields. You can make queries, which are essentially select statements. You can make mutations, which are insert or update statements. You have scalars, where you can say that this is a custom data type that I want to use in my data definition. You can use that as a scalar. So let's say you want to allow JSON, just JSON to work with your data, and you just want to allow that to either query or mutate. You want to allow a very loosely scoped kind of a query. You can use scalars, and of course the resolver, that actually is your function that translates all of these type systems into your database queries. So your function essentially is written to translate all of this stuff into your database queries. So let me just give you a quick tour of GraphQL. In fact, this is not a fully done GraphQL yet, so I'm converting a lot of thread playbook into GraphQL. So one of the layers that I'm going to show you now is how thread playbook works with GraphQL. So let me just show you how it works. It's quite simple to understand. So I think I'm already running the server. Yeah, it's already running. So I'm just going to access this URL. So this is my GraphQL. So GraphQL, you have a lot of client-side tools that allow you to query and use GraphQL. You can see that it's pretty much near real time, right? You can actually query real time. The query changes in real time. And you can see that there is only one URL that I'm actually querying. I'm not querying a bunch of URLs. So all of these, the query itself goes as an HTTP post request. So the query itself goes as an HTTP post request, and that's how it works. So you don't have put, delete, all of that stuff. You just have HTTP post. One of the other things in GraphQL is you don't have HTTP error codes as well. You just have HTTP 200. The error is always inside of the JSON that comes back, right? The data that actually comes back, the error is in that data set, or the error is represented in there. You don't have 400, you don't have 500. You typically don't see standard HTTP error codes like that. So let's look at a quick query. So I have a bunch of objects that I have written in here. I have vulnerabilities, projects. Threat playbook is about user story driven threat modeling. So I have user stories, abuser stories, and so on and so forth. So let's look at how I can query something like this, right? So let's look at a simple query for vulnerabilities. Now I'm going to query all the vulns, except I'm not going to query all the fields. I just want the name and I want the description. That's all I want. So let's start with the name first. I'm going to say name, and I'm going to run the query, and it's just going to come back with the names of all the vulnerabilities in my database, right? That's it. It's just all the vulnerabilities in my database and all the names of those vulnerabilities. So I'm not querying any unnecessary information. If this was a REST API, I would say, vulns, and it would come back with this massive JSON structure with the name, the CWE, the description, the observation, the ton of that stuff, the request, the response. If it was Zap, it would probably come back with HTTP request, HTTP response, method, body, all of that stuff. I don't need any of that stuff. I just need the name. Let's say now I need to query the description. I just query the description, and it automatically queries that description, comes back with the description. So I can do that. I can also start quickly querying nested objects, right? So I can say query this object, which is user stories, and every user story in my case has a short name. And I also want to query the abuser stories related to that user story. So that's the feature here. So every user story has a bunch of associated abuser stories with it. So I'm going to query the abuses object, and I'm going to say, give me the short names of the abuses as well as the description of those abuse cases that I'm writing. So it gives me the user story, which is the short name here, and all of the abuser stories associated with that user story. So this way I can actually customize my queries quite extensively, right? I can write multiple select queries in the same query. I don't have to query one at a time or all at a time. It's not a one or all kind of a thing. I can actually get quite flexible with the way I query the system, or I mutate the system, and so on and so forth. Similar thing with mutations. Mutations are pretty simple as well. So mutations, essentially, in this case, I've written only one mutation, so I'm going to show you that mutation. So I have one mutation which essentially adds a project or creates a project. So I'm going to say create project. I give it a name, and I say OWASP AppSec Cali 2019. And I come back with the status of that mutation, and I also come back with the project, and I come back with the project name. So once I update or I mutate the project, I come back with the status of the update of the insert, and I want to show the name of that particular project that I've just created. So it says, duplicate, okay. Let me just do 2020 because let's look forward, right? So I have you can see that the error also came back in the same thing. So it was error 200, but nevertheless, you can see that it came back with the project, and of course the project name AppSec Cali 2020. So mutations, I can do subscriptions, I can do a whole bunch of stuff. I'm not going to get into subscriptions because that's a whole different feature. I want to focus on the attack first. So let's get moving so why serverless in GraphQL? Simply because I think it's going to be pretty big moving forward. You're going to see a lot of stacks that are going to have serverless in GraphQL, especially for the pricing advantage, right? Especially for price. You're going to see a bunch of stacks deployed simply because it's really cheap running stuff on serverless and GraphQL. So I would say that this is going to be a big business decision that a lot have. Of course, in our industry, we always have neo mania, right? As soon as we see something new, we want to run and jump and implement it. So this is something that we're going to see with serverless and GraphQL as well. I'm sure we'll see this often as we move forward with these technologies. And again, it's super easy to deploy. Why wouldn't you, right? This is the deployment spec for my GraphQL and serverless function, right? It's literally this. That's all it takes. So it's really easy to do. So the whole approach of having to deal with the deployment and managing the deployment is really not there. So it just becomes that much easier to work with it. Amazon and a lot of these providers already provide a lot of tools for it. Like it's AppSec, for instance, is one of the tools that allows you to do serverless and GraphQL. And it's supposed to be really good. I've not tried it out myself, but even without any of those managed services, you can easily run serverless and GraphQL together. Now, security considerations for serverless, again, one of the things you should keep in mind is that there is no real framework, right? You don't have Django, you don't have Flask, you don't have Spring, you don't have any of that stuff. You're typically writing your plain old Python, plain old Java, plain old JavaScript, etc., etc. Right? So you don't really have input validation, output encoding, you don't have all of the good stuff that comes with frameworks. That's one of the big challenges with functions as a service. Of course, you don't have any network attack surface, which is nice. Observability and debugging is a massive pain. I don't know how many of you have written serverless, but you'll probably realize that logging and figuring out what actually the function is doing is a super painful thing. It's a pretty huge challenge, and I think a few companies are trying to solve it, but I'm not sure how good they've gotten with that. Of course, you have events from multiple sources, which means that your attack surface is now gone up quite a bit. Okay, so I'm going to move forward a little bit. So no frameworks obviously means no batteries included. DIY validation, which means you have to do everything yourself, and we know all of us know how good we are at doing such things, right? So how good we are as an industry at doing our own validation, doing our own access control, doing our own logging per function, all of that stuff. Things we don't do too well, we have to end up doing now, a lot of, right? So that is something that I believe we're going to see a lot of with GraphQL and serverless. Observability, I've already mentioned this. I'm going to move on. Sorry about that. And of course, you have events from multiple sources, which means that you can't just put a WAF in front of your API and forget about it, right? You have S3 triggering flaws. You have SQS events triggering flaws. You have events from various sources that might trigger flaws. So you have all of those security considerations to think about. So traditional security controls like WAFs or even DAST, for instance, will not really work with a lot of serverless functions. Not all of them, of course, but it will not work with a lot of serverless functions. Again, GraphQL as well, I'm sure we'll see some challenges with a lot of security tooling working well with. Right? So useful projects, one, of course, I have to plug my own project, which is, of course, it's open source. It's damn vulnerable functions as a service. It's on GitHub. OWASP has OWASP Serverless Top 10, which you can look into. It also has the guide and an app associated with it. So you should look into either of these or both of these. Really doesn't matter. So let's start with the attacker's view. I have a few demos here and then with GraphQL, and then we can So essentially with functions as a service, like I mentioned before, I think one of the bigger attack vectors that we're going to see moving forward is with attacking the functions that are non-HTTP or non-API gateway driven. Like, for instance, let me give you an example, right? So let's say I run a recruitment company and I allow users to, through my app, upload stuff over to S3, right? Upload their CVs or resumes over S3 or to S3. Now, as soon as I upload it to S3, I trigger an event saying that, hey, function, read S3, read this file in S3, store it in my DynamoDB thing, and then do AI or whatever analysis I want to do on top of it after that. Now, let us say the user uploads a docx file, right? A docx file, which a lot of people upload resumes and stuff, right? Now, let us say they upload a docx file which is loaded with a XML external entities payload. And I am parsing the docx file with the same vulnerable XML parser. I read it, obviously triggers a XML external entities injection, and I pwned at that point in time, right? So you can see that the attacker is not really attacking the function per se. The attacker is out of band attacking the function, right? So it's a more out of band execution that's happening with this function, and that's why you are having these kind of triggers. So let me just quickly show you one of the examples, and this is called function data event injection, where you inject payloads or you inject attack vectors through the non-HTTP or out of band mechanisms that trigger that particular function, right? So this, of course, you can have over multiple things. You can trigger it over S3. You can trigger it over the notification service. Let's say a message is received via the queue, and that message has some kind of a SQL injection payload, and that is accessed by your database. That would be a pretty big problem. So you can have multiple events that are causing your injection attacks to happen, right? So again, this could be command injection. We're going to see definitely a lot of SQL and NoSQL injection happening as well. Deserialization is pretty big, and I'll show you what was some of the outcomes of attacks that give you access to or remote code execution to that particular function, right? So this is a simple case. I'm going to simulate this case. The user uploads an XML file to S3. My function is running a really crappy parser, XML parser, which is vulnerable to XML external entities. I read the XML, and of course, the user is now able to do something which is malicious, right? Anything malicious. So let's look at our example here, and I have set this up. So I'm just going to upload an XML file, and this XML file is a malicious XML file. I'll show you what is happening in this XML file. It's called maliciousxml.xml. So I'm just going to quickly show you what's happening in here. And these examples are in dvfast, by the way. So you can, if you run dvfast, you will have all of these examples in the project. So this XML file is going to pull the etc password and hopefully load that in the database. So what's happening here is multiple things. You have your function that is triggered as soon as something is uploaded in S3. So S3 upload happens, object create event is triggered. Function reads that XML. Of course, when it's reading the XML, it's going to resolve these entities, and one of the entities it's going to resolve is etc password. So let's look at what's happening here. I'm going to upload this XML. Of course, I'm not directly attacking the upload feature itself. I'm just uploading to S3, and it's going to upload, and my file, it's going to store in the database, and then my file is going to show up here, and you can see that now I have the etc password listed. Of course, in a function or in a ephemeral container or VM, this may not be too much of a threat model, or etc password may not mean anything even, but you could do SSRF. You could, let us say, a lot of files stored in the /temp directory. You could have some sensitive files. Source code disclosure could happen through these kind of attacks. So you would have some impact depending upon how your function is set up and how it's running. So this is an example of a function data event injection where you're triggering an attack or an injection payload through an out-of-band mode and getting your function to actually fall prey to it. Essentially, that's what's happening here. The other example that I quickly have is, imagine that you receive a text message, right? So Amazon has these message gateway services like simple notification service and so on. Now let us say you could trigger a function when a text message came in. And this function, let's say your text message has some SQL injection payload, and that's essentially what the simulation is all about. So this message that we're going to send is going to have a bunch of SQL injection payloads. So let me just show you the payloads that I'm talking about. So this is the these are the payloads. It's going to run this. It's going to send it to your simple notification service. And once it sends it to the simple notification service, my function would try and read it. Of course, it's using a non-parameterized SQL statement at this point in time. As a result, I trigger a SQL injection on an insert statement as opposed to a select statement, which is what you typically see with SQL injection, right? So let's look at this. I'm just going to run this. So I'm just going to deploy the payloads. And if I go back to my database, you would see that, I don't know whether you can see this, but you can see that instead of the actual sensor reading, I've actually been able to dump the database, the current database, the user. So think of it like SQL injection with template injection kind of a payload here, where we've actually been able to trigger a SQL injection through a text message or an out-of-band notification service message that comes in, right? So these are some of the attacks that is possible with functions as a service. I'm going to try and see if I can do more. I've already seen this. Again, one of the problems with this, obviously, challenges, it's hard to test for, right? You can't test for this unless you are really, you know the function really well, or you're actually, security testing teams are going to find it hard to test for sure. You can't deploy WAFs and stuff in front of this simply because you don't really have the attack coming in over the API gateway. It's coming in over third-party sources, third-party notifications and events. So you don't really have WAFs that you can typically deploy for something like this. You, of course, also have privilege escalation attacks where, let us say, your function is given a lot of privileges, or the role is extremely loosely scoped, and then through that you can attack other aspects of your AWS or your cloud service account. So let me just show you a quick screenshot. It's not really a screenshot, I think it's more a live. So this is a, now this, let me just try and increase the size. Not able to zoom in. Anyway, so what's happening here is I've triggered an insecure deserialization attack on a function, right? Now this uses the Python YAML.load deserialization. How many of you are familiar with that? YAML.load deserialization technique, where I can upload an arbitrary YAML file with Python object code in it, and it would remote code execute. It would just randomly load that YAML file in memory. So in this case, what's happening is I have uploaded a malicious payload file which is going to retrieve all the environment variables of that particular Lambda function. And AWS, if you're associated with EC2 or you're familiar with EC2, EC2 has 169 that interface which has the metadata, right? The metadata of a function is in the environment variables. So you have your AWS key ID, your secret, you have your session token in the environment variable. So if you can dump the environment variables, you've pretty much pwned the entire function. The role of the function now you can access as that function's role and pretty much gain whatever access you want to that particular AWS account and the resources associated with that account. So you can see that it actually has the access key ID, secret key, session token, all of that stuff in the environment variable. So if I can dump the environment variables or some of the process related to that, I can actually pull all that data and use that to escalate privileges on my AWS account. I had another demo, but I don't think I'm going to have time, so I'm going to move it quickly. I have there's another one called DynamoDB injection. You can read about it. It's on my Medium page. It was an attack that I identified about a year back. So that's interesting. It kind of relates to what I'm talking about here. I'm going to quickly go to GraphQL because I'm really short on time. So GraphQL, of course, again, it's one of those things that is largely DIY at this point. Access control, input validation, query whitelisting, all of the good stuff that you want to do with GraphQL, you have to do it yourself, right? So unfortunately, GraphQL does not, just like serverless, you still have a lack of frameworks that allow you to do a lot of the good security stuff with GraphQL. They're building it quite a bit. In fact, Apollo and all these frameworks are building in a lot of safeguards for GraphQL, like query whitelisting and so on and so forth. But still, if you're using Python or if you're using, let's say, Go or whatever it is, the tooling for many of these languages are not that great, to be honest. So you still have to do a lot of this yourself. You still have to manage a lot of this yourself, right? So attacker's view of GraphQL. GraphQL in many ways is going to be very similar to a web application or a web service, the kind of flaws you would see, except that we would see, I think that we're going to see a lot more authorization flaws. I think we're going to see a lot of NoSQL injection flaws, right? Especially because NoSQL injection, GraphQL requires you to kind of loosely scope the query when you're searching for things and so on and so forth. So we'll see NoSQL injection bugs kind of taking center stage. We're also going to see a lot of denial of service. When it's coupled with serverless, I think we're going to see a ton of denial of service attacks, which will cause your build to just shoot through the roof. And I'll show you a demo a little bit later. Let's move on. One of the things with GraphQL is that it has an ability to do introspection. So which means you can actually query the API or query the GraphQL and come back with all the fields and objects and types that it supports, right? So for instance, let me just quickly query my GraphQL layer with that data. I can actually get all of the different queries and stuff. So I'm going to just run this introspection query. And this will give me all the types that are in my GraphQL layer. So you can see that so think of these as database tables, right? All of these are database tables that now I can access and query and do whatever I want, or typically perform some kind of operations with. I can also go a little deeper. Let us say I want to query the type vulnerability with all the fields that it's associated with. I can say, boom, give me all of the vulnerability fields. It'll tell you that it has all of these different fields. So when how many of you have used SQL map and stuff like that here? SQL map to do SQL injections. You would probably want to use similar techniques, right? With SQL map, where you go in and you find the current database, the tables, you dump the rows, you dump the columns, and so on and so forth. You do that as a feature in GraphQL. I'm not saying it's a bad feature. It's meant to be a feature, but the idea is a lot of people don't disable introspection, and as a result, you kind of have this entire layer open that anyone can query. And imagine a lot of these could be sensitive fields, right? Let us say one of the examples I'm going to show later is a field in a user type which is called isAdmin. Now, I should not have to know that isAdmin is a field that I can access and do something with, because I can change that and become admin. Right? So the thing with GraphQL is that if you don't lock down the introspection layer, you can get willy-nilly. At least you'll have a lot of information disclosure associated with that. Okay. I'm going to quickly move ahead. How much time do I have? Oh, sheesh. Sorry about that. I have 3 more demos, 2 minutes each. Is that okay? Okay, thank you. Appreciate it. So again, I'm going to move forward. Not this introspection, of course. We are talking about this introspection. Authorization bypass. GraphQL, I think we're going to see a lot of mass assignment, right? Now, this is a vulnerability, I don't know when it dates back to, I think 2013 is when we saw a lot of mass assignment in Ruby, right? Ruby was where we saw a lot of mass assignment bugs hitting us, and GitHub was compromised based on a mass assignment flaw. In this type of flaw, what typically happens is that there is a model that you frame, and the attacker essentially sends all of the fields or all the attributes serialized in a particular format, in maybe base64 or maybe JSON or whatever it is. And once the application receives it, the application deserializes and just dumps that as and creates an object from that and dumps that into the database. Now with GraphQL, we are likely to see a lot of these type of attacks, simply because now we have introspection. Because if an attacker can gain access to your introspection layer, the attacker can gain access to what are the different fields in your layer, and then start manipulating some of those fields to start tampering with authorization privileges and gain access to a lot of sensitive functionality that the attacker should not have. This is a video demo. I'm just going to kind of play it and see. It's going to be. So I have a mass assignment flaw that we have simulated for this. So in here, the user has every user can be an admin if, of course, the privileges are granted for that user. So what we're doing is we're creating a bunch of users, and this user should not have access to administration. So the user should not be able to manipulate the configuration object, and that's something that we're blocking out in this demo here. So the user does not have access to perform configuration changes and so on. And you do have an isAdmin privilege here, so the user does not have access to these privileges. Now, if the user tries to perform this action, the user essentially comes back with a, sorry, internal server error, you're unauthorized to perform. However, on the update feature of this, we've just provided a JSON where the user can update with a JSON. And if the user puts in isAdmin:true in the update profile feature, the user now has changed his status to administrator, and the user can now change the configuration and obviously update sensitive information and so on and so forth, right? Change the configuration and do all of that stuff, right? So this kind of attack, I'm sure we'll see a lot more of in the GraphQL world. Injection is something, I'm not going to look at injection because I think injection is straightforward. I think a lot of us. Denial of service is something that I believe is going to be pretty big in the GraphQL world simply because of nested statements. So let us say, let's take two objects, right? You are a user and you can be part of a team, and a team can have multiple users. So you can have a nested query where you can query the user, the teams, the user, the creams, the user, the team, the user, the team, and you can create this nested approach, and you can perform a denial of service attack. And this would kind of run all your CPU cycles and kill your function. So in this case, one of the videos I'm going to show you next, we are running this in a Lambda function where we have this query, this sort of query that we're going to use. So we're going to use the user and the teams that the user is associated with, and we're going to build that query as a nested query. Right? You can see the teams and the name of the team, and then from the team we're going to get the user from of that particular. So you can see that the user, the name, the team, the name, the users. Again, so it's going like a nested relationship that's coming down, and at the end of the query you'll see that we have 4,698 lines of nested query built in, and this takes. This is running on a serverless function, by the way. Amazon throttled us after this. So what happened was it ran for 40 seconds. And this single query cost us $3, which means that if you run this query, let's say 1,000 requests per minute, if an attacker runs this query 1,000 requests per minute, your Lambda bill is going to be $8,000, give or take. So you can see that it's going to run for about 30 to 40 seconds now. And it's going to take whatever time it takes. So this attack essentially took, the single request cost us $3. But if this is scaled, you can see that it's going to cost you thousands of dollars, especially if you're a public-facing site that someone can potentially do this. Right? So GraphQL, I think DOS is going to be a pretty big payload, especially when it's on serverless, because serverless, one of the big reasons we go in for serverless is because of the cost. And if that is kind of shot out the window, then you're going to see a lot of bills that you're going to incur that you don't want to incur. Right? So with that, some conclusions. I think that these two framework or these two pieces of technology are going to be used quite extensively moving forward, simply because of the business benefit they bring in and the deployment benefit that they bring in. However, this is largely currently DIY. You have to do this yourself. A lot of this has to be done yourself. So this would require a lot more discipline in terms of input validation, output encoding, all of the stuff that we are not traditionally good at as an industry. So we need to really think about how we do this in terms of deploying stuff for writing code for serverless and GraphQL. Security tooling, I think we have a lot to catch up on, especially dynamic testing. Static code reviews are tough, especially because a lot of these are cloud libraries, and static code reviews don't really catch a lot of security flaws with cloud libraries and so on. So I think there's a lot of work that needs to go into this. Thank you. I'm sorry for running over time. My Twitter handle, you can follow a lot of stuff we do on this space. Thank you very much. Any questions? Thank you.